Hello and welcome back to Mech Zone. Today we shall be starting with the chapter on calculus. And before starting this chapter, I would simply like to tell you all the topics that we are going to study. We are going to study about the limits of the functions. Then we are going to study about the continuity. And we are also going to study about maxima and minima. Maxima and minima. However, I shall be skipping the integration and the differentiation part. Why? Because and we also have the topic of mean value theorems. Then we'll not be studying integration and differentiation, but some important parts, that is about derivatives. We'll be studying about the derivatives, and we will also be studying about the vectors in this chapter. So all these topics are going to be covered in this chapter of calculus, and this lecture is going to be about 1 hour or 1.5 hours depending upon the content. So let us start with this chapter. Okay, so let us start with the first topic, that is the limit of a function. So the limit of a function at a point, we will be first discussing about the limit of a function at a point, and a function f of x is said to have a limit when x is tending to a. Okay, this sign refers to tends to a if for a given epsilon greater than 0 there exists a delta such that this delta is greater than 0, such that f of x minus L mod is less than epsilon, or mod of x minus a is less than delta. Okay, so this is the actual definition for the limit of a function, and this two vertical bars simply means, or it measures the absolute value. It measures the absolute value, or simply the distance in terms of vectors. Okay, for example, we have fx is equals to 1 upon x square, and if the limit is tending such that x is tending to 0, so f of x, that is limit x tends to 0, 1 upon x square. Now we see, or if we draw the graph for this function, we will have, say this is the y-axis, this is the x-axis. So this is going to be the graph for 1 upon x square. So if x becomes 0, 1 upon x square will become infinity. Okay, and for the graph fx is equals to 1 upon x, the graph is going to be somehow like this. Okay, so limit is not existing. It means the left hand side and the right hand side of the limits are not equal. Hence right hand side limit is not equals to the left hand side limit, and therefore we are going to say that the limit does not exist. Now what do we mean by the left hand side limit and the right hand side limit? For example, if the value of x is approaching from the right side, then we have the right hand side limit, and if the value of x is approaching from the left hand side, then we have the left hand side limit. And for the right hand side limit, what we write is limit x tends to a plus 0 f of x. So this simply becomes limit x tends to a plus f of x. This is representing the right hand side limit of the function. Okay, and what is the working rule? The working rule states that we, instead of a, we have to place a plus h. Okay, we will keep a plus h and we will make h approach to 0. So f of a plus 0 simply becomes limit h tends to 0 f of a plus h. Okay, so this was about the right side. Now similarly, if the x is approaching from the left hand side, that is x approaches from the left side, and we are going to follow the smaller values of x than a. Okay, now from the left hand side, the values of x will now going to be smaller than a. So the limit is called as the left hand limit, and it is represented by limit x tends to a minus 0 f of x, or simply f of a minus 0, or limit, either it can be LT or LM depending upon your convention, a minus f of x. So this is called as the left hand limit and this is called as the right hand limit representation. So what we are going to do is we are going to find out both the left hand limits and the right hand limits, and if they are equal then we will say that the limit is existing, else the limit does not exist. Now we will discuss about some standard limits. Some standard limits, and the standard formulas needs to be remembered because sometimes direct formulas can also be asked. So limit x tends to a, x to the power n minus a to the power n upon x minus a equals to n a n minus 1. Then limit x tends to 0, sin x upon x is equals to 1. Now these limits can simply be obtained by applying the L'Hopital's rule. L'Hopital's rule को apply करके हम लोग अपने limits को evaluate कर सकते हैं. Then limit x tends to 0, tan x upon x, this is also equals to 1. Then we have limit x tends to 0, e to the power x minus 1 upon x, this is also equals to 1. Then limit x tends to 0, a to the power x minus 1 upon x, this is simple ln a, and ln is representing the natural log such that the base is e, and the log a simply represents the basic log and the base is 10. Here the base is e, here the base is 10. Now limit x tends to 0, 1 minus cos mx upon x square, this is simply m square upon 2. Then limit x tends to 0, 1 minus cos mx upon 1 minus cos nx, this is equals to m square upon n square. Then we have limit x tends to 0, 1 plus x to the power 1 by x, this is simply equals to e, and limit x tends to infinite, 1 plus 1 upon x to the power x is equals to e. So these two are important cases. Okay, next we have limit x tends to infinite, 1 plus a upon x to the power x upon a, this is also equals to e. So these are the important cases, and one more case we have limit x tends to infinite, sin x upon x is equals to 0. So this can be deducted from a very simple logic, that is any finite number upon infinite number, because if x is tending to infinite also, then sin x is going to be a finite number and x in the denominator will be infinite, so finite upon infinite is generally 0. Okay, now that was all about the limits. Now we will discuss about the continuity of a function at a point. Now continuity of a function, the function f of x is said to be continuous at a point x is equals to a if limit x tends to a, f of x, this is simply equals to f of a. If this is taking place, then it is said to be continuous at a point x is equals to a. That is limit x tends to a minus f of x is equals to limit x tends to a plus f of x, this is simply equals to f of a. So if the left hand limit and the right hand limit are both existing, then it is said to be continuous at a point x is equals to a, such that the left hand limit is equals to the right hand limit is equals to the f at a, that is the value of the function at the point a. Now if we have, for example, f of x is equals to x plus 3 upon 3 when x is less than 3, 2 when x is equals to 3, and x minus 1 when x is greater than 3. So what we're going to do is we are going to check for the left hand limit and the right hand limit. So first for the left hand limit, x tends to 3 minus, less than 3 means 3 minus x plus 3 upon 3. So instead of this is a minus, we are going to write a minus h. So this would be 3 minus h plus 3 upon 3. So this is equals to, and this is limit h tends to 0. So this will be 2 because 3 minus 0 is 3. 3 plus 3, 6 upon 3 is 2. Now limit x tends to 3 plus, that is greater than 3. So x minus 1, this is limit h tends to 0. 3 plus h minus 1, this is also equals to 2. So left hand limits and the right hand limits both are equal, which is equals to 2, and hence the function is continuous at x is equals to 3. And for continuous functions, the graph of those functions will be well connected. The graph of continuous functions are generally well connected. Okay, so this was about the continuity of a function. Now we will study about the derivative of a function at a point. Derivative of a function at the point. A function f of x is said to be derivable at a point x is equals to a if limit x tends to a, f of x minus f of a upon x minus a is having a finite value. So if f of x minus f of a upon x minus a is having a finite value, then the function f of x is said to be derivative or derivable at the point x is equals to a. And this also simply means that limit x tends to a minus f of x minus f of a upon x minus a should be equals to limit x tends to a plus f of x minus f of a upon x minus a. That means the limits are also same, and the left hand derivative is equals to the right hand derivative, and they both should possess a finite value. So let us do a question. F of x has been given as x square sine 1 upon x where x is not equals to 0 and 0 when x is equals to 0. Now f dash 0 will be limit x tends to 0 f of x minus f of a upon x minus a. So limit x tends to 0. F of x simply means x square sine 1 upon x minus 0. F at a is 0 upon x minus 0. So this is coming out to be x square sine 1 upon x divided by x, limit x tends to 0. Okay, so this gets cancelled out and hence x sine 1 upon x. Okay, so we will assume, or we can also write it as sine 1 upon x whole upon 1 upon x. So this can be written like this, limit x tends to 0. Now let 1 upon x is equals to t. So limit t tends to infinite, or t tends to infinite sine t upon t. So we have already studied this, that from the standard result this comes out to be 0. Since it is coming out to be 0, it simply means that it is differentiable at x is equals to 0. And there is an important point to be noted here, that every differentiable function is continuous, but every continuous function may or may not be a differentiable function. For example, if f of x is equals to mod x, then this function is continuous for all the values of x. But if we look at the differentiability or the derivability of this function, it is not derivable at x is equals to 0. If we plot a graph of mod x, then it would come out to be like this. This is the y-axis, x-axis. This is y is equals to minus x. This is y is equals to plus x. So it is not derivable at the point x is equals to 0. Derivable simply states that if the function is derivable, then there will be an existence of slope. So differentiable function simply means that the slope will exist, and the slope of the curve and the tangent is also existing for a differentiable function. It simply means that a tangent can be drawn. A tangent can be drawn for a differentiable function. At this point we observe that a tangent cannot be drawn because at the sharp point infinite number of tangents are possible. So if we look, this point is minus 1, this point is plus 1, the left hand limit derivative is equals to minus 1 and the right hand limit derivative is equals to plus 1 at this point 0. So this function is not derivable at x is equals to 0. Okay, so that was all about the derivability of a function. And now we shall be starting with the mean value theorems. Okay, now in the mean value theorems, the first theorem that we have to study about is the Rolle's theorem. Okay, in the Rolle's theorem, if f of x is a real valued function defined on the closed interval between a to b, and first it is f of x is continuous in the closed interval a to b, second it is f of x is derivable in a comma b, third f of a is equals to f of b, then there exists a point c such that this is included between a and b, and f dash c, this is equals to 0. So this is the main point in the Rolle's theorem, such that at the derivative at that point c is coming out to be 0. So what is the geometrical meaning if I draw a graph? This is the y-axis, this is the x-axis. If this is a curve, okay, then the curve is actually becoming parallel to the x-axis at this point, and this point is nothing but the point C. This point is corresponding to A, this is corresponding to B. This is x is equals to B, x is equals to A. So geometrical meaning is, for a real valued function, a graph can be drawn between the points x is equals to A and x is equals to B. The graph is going to be well connected, and hence it is a continuous function. Now from A plus to B minus in open interval, this is called as the open interval. Open interval simply means that the A and B values are not included. Rest in between A and B, all the values are included, and in the closed interval, all the values including A and B are also included. So अगर हम देखें अपने open interval की बात कर रहे हैं, so for the open interval the function is derivable only, the function is derivable on every point between these 2 points A and B. So f dash c is equals to 0. It simply means that slope is equals to 0 at least at one point, and this is the point where the slope is 0. That means this, when the axis becomes parallel to the x-axis, then the slope is 0. Okay, so this was about the Rolle's theorem. Now we will go for the Lagrange's mean value theorem. So if you have not subscribed to our channel yet, kindly do it and also press the bell icon so that कोई भी अगर important update हम upload करते हैं तो सबसे पहले आपके पास वो notified हो जाए, और अपने friends और colleagues को भी हमारे channel के बारे में बताइए so that they are also benefited, because this is the only channel on YouTube which is providing the exclusive quality video lectures for mechanical engineering for the preparation for different examinations like public sectors, IES, गेट, SSC, JEE etc. सो आप अपने फ्रेंड्स को भी कहिए वो हमारा चैनल सब्सक्राइब करें, और आप सारा का सारा स्टडी मटेरियल जो है एब्सोल्युटली फॉर फ्री एक ही कॉन्सेंट्रेटेड पॉइंट से हमारे चैनल्स के थ्रू आप डाउनलोड कर सकते हैं. यू कैन ऑल्सो रेट आवर फेसबुक पेज, हमारा फेसबुक पेज भी है और वहां जाके आप अपनी प्रॉब्लम्स भी शेयर कर सकते हैं. So in the Lagrange's mean value theorem, if we have a function f of x such that this is a real valued function in the closed interval between a to b and it is continuous in the closed interval and it is derivable in the open interval, okay, then there exists at least one point c which is lying in between a and b such that f dash c is equals to f of b minus f of a upon b minus a. So this is the important point in the Lagrange's mean value theorem. Okay, now we will draw the graph corresponding to this. Y-axis, x-axis, okay, so this is corresponding to the point A, this is corresponding to the point B, and this is corresponding to the point C. Okay, so this is B comma f of B, this is A comma f of A, the coordinates of these points, and these lines are actually parallel to each other. This line and this line are actually parallel. So from A plus to B minus, the graph is well connected. Okay, the graph is well connected and also the function is derivable. So this is continuous as well it is derivative. And if f of A is equals to f of B such that f dash c becomes 0, then it will simply give you the Rolle's theorem. Okay, it will simply give you the Rolle's theorem. So Lagrange's is the first mean value theorem. Okay, Lagrange's is also called as the first mean value theorem. Now we have a Taylor series, and if f of x is continuously differentiable at a point x is equals to a, then f of x can also be expressed as f of x is equals to f of a plus x minus a into f dash a plus f double dash a upon 2 factorial into x minus a whole square plus so on. And for a is equals to 0, if we put a is equals to 0, we will obtain Maclaurin series. And for the Maclaurin series, we obtain f of x is equals to f of 0 plus x into f dash 0 plus f double dash 0 upon 2 factorial into x square plus so on. So based upon this, we have found out what is the series for sine x. This is x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial and so on. And cos x simply is 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial and so on. E to the power x is 1 plus x square upon 2 factorial plus x cube upon 3 factorial and so on. E to the power minus x is 1 minus x plus x square upon factorial 2 minus x cube upon factorial 3 and so on. So these series are actually obtained from the Taylor series, or we can say that they are deducted from the Taylor series. Now another important, that is ln 1 plus x. This is x minus x square upon 2 plus x cube upon 3 and so on. And ln 1 minus x is minus x square upon 2 minus x cube upon 3 minus x4 upon 4 and so on. So we have to remember these two series because they are very important, and the questions can also be directly asked what is the formula for ln 1 plus x expansion and ln 1 minus x expansion. Now let us discuss an important type of problem which can be asked in the GATE or any important examination, such that we have been given function to the power of a function. Then for such type of problems, what we do is we take the log. Okay. For example, we have been given e to the power x cos x to the power of 1 upon sine square x, limit x tends to 0. Now we have been given this. What we do is let L is equals to limit x tends to 0 e to the power x cos x 1 upon sine square x. And now what we'll do is we'll take the logarithm on both the sides, that is ln L is equals to limit x tends to 0 ln e to the power x plus ln cos x to the power 1 upon sine square x. Okay, now this can be written as limit x tends to 0 ln e to the power x plus 1 upon sine square x ln cos x. Okay, so what we're going to do is we will simplify, and on simplification this simply becomes limit x tends to 0 x plus here also limit x tends to 0. I missed out. Limit x tends to 0 and limit x tends to 0. So this simply becomes limit 1 upon cos x into minus sin x upon 2 sin x cos x. So sin square theta, sin square x को हमने ब्रेक कर लिया एंड ये भी हमने ब्रेक करके अपना आ गया ये वाला फॉर्म. So sin x will be cancelled out and hence we will get ln L तो हमारे यहाँ था ही, तो ln L is equals to this would be 0 minus what we are going to obtain cos x भी कट गया तो 1 upon 2. So L is equals to e to the power minus 1 by 2, क्योंकि हम लोग यहाँ पर जब एंटी लॉग लेंगे तो हम ln को यहाँ भेज देंगे तो हो जाएगा e to the power minus 1 by 2. Okay, now we will discuss another question which is based on the differentiation, and with that we will be revising our differentiation a little bit. X is equals to a theta minus sine theta, y is equals to a 1 minus cos theta, and we have to determine the value of dy by dx. We have to determine this value. So what we will do it first, we will find dx upon d theta. This would be a 1 minus cos theta, and we will find dy upon d theta. This would be a sine theta. Simple differentiation. Now dy by dx can be written as dy by d theta into d theta by dx. So this is simple, but a upon sine theta divided by a 1 minus cos theta. So a gets cancelled out. So we obtain sine theta upon 1 minus cos theta. Now sine theta can be written as 2 sine theta by 2 cos theta by 2. And 1 can be written as sine square theta by 2 plus cos square theta by 2 minus cos theta can be written as 2 cos square theta by 2 minus 1. So please remember this identity. Cos 2 theta is equals to 2 cos square theta minus 1, and if we are writing cos theta then it would be 2 cos square theta by 2 minus 1, and this is also equals to 1 minus 2 sine square theta upon 2. So we have to remember this identity. Now further if we will solve, we will get, so cos square theta, 2 cos square theta will be cancelled out, and after simplification we will obtain 2 sine theta by 2 cos theta by 2 upon 2 sine square theta by 2. So 2 gets cancelled out, sine theta से a के power चला गया, so we obtain cot theta by 2. So dy by dx is nothing but cot theta by 2. So this is the answer for this question. Okay, now we will start with the topic of total derivative. Okay, so if u is actually a function of x and y, where x is a function of t and y is also a function of t, then the total derivative of u with respect to t is given by du upon dt is equals to del u upon del x into dx upon dt plus del u upon del y into dy upon dt. So this is actually the formula for the total derivative of u with respect to t. And if u is a function of xy, where x is a function of rs, y is a function of rs, then how we are going to write u? U can be simply written as u r is equals to ux xr plus uy y r, and us can be written as ux xs plus uy into ys. Okay, so this is how the u can be expressed. Okay, now what we're going to do is we are going to discuss something about Jacobian. So if x is a function of u and v and y is a function of u and v, then the Jacobian of x and y with respect to u and v is simply given as j xy upon u comma v is equals to del x upon del u, del x upon del v, del y upon del u, del y upon del v. This is nothing but simply the Jacobian of x and y with respect to u and v. Okay, now let us do a small question. If x is equals to uv and y is equals to v upon u, then find out the Jacobian of x and y with respect to u and v. Now simply the determinant del x upon del u is simply v, then del x upon del v is simply u, then del y upon del u. Del y upon del u is nothing but minus v upon u square, and del y upon del v is simply 1 upon u. So when you will take the determinant, or when you will solve the determinant, you get v upon u plus v upon u, and this is simply but 2v upon u. So this is the answer to this question. So now let us discuss about homogeneous function. Homogeneous function. A function f of xy is said to be homogeneous function of degree n if f kx ky is equals to k to the power n x comma y. This is a very important definition of a homogeneous function, that is a function f of xy is said to be a homogeneous function of degree n if f of kx and ky is equals to k to the power n xy. For example, if we have f of xy, this is equals to x to the power 8 plus y to the power 8 upon x minus y. This is actually a homogeneous function of degree 7. Why degree 7? Because x to the power 8 is in the numerator and x to the power 1 is in the denominator. So power will be subtracted according to the law of indices, and hence the power or the degree becomes 7. Okay, whereas if f is equals function of xy, this is equals to x to the power 8 into y to the power 8 upon x minus y. So this function is homogeneous of degree 15, because 8 plus 8, 16 would be there, and 16 minus 1, it would be 15. And if we take the example of f of xy such that this is x to the power of 4 sine inverse x upon y plus y to the power of 4 cos inverse x upon y. Now this function is not homogeneous. Why it is not homogeneous? Since the degree of the first term is not equal to the degree of the second term, but separately they are homogeneous. ये मतलब इतना part homogeneous है और इतना part भी homogeneous है, लेकिन completely they are not homogeneous. Similarly, we have sin inverse x to the power of 6 plus y to the power of 6. This is also not homogeneous. Okay, this is also not homogeneous. Now we will discuss about an important theorem which is called as Euler's theorem. वैसे तो इसका करेक्ट pronunciation is Euler's theorem. It is not Euler's. पिछले भी लेक्चर में मैंने Euler बोला था, but that is wrong. The correct pronunciation is Euler's theorem. So if u is a function of x, y, and this is a homogeneous function of degree n, then first x into del u upon del x plus y into del u upon del y, this is equals to nu, and x square into del square u upon del x square plus y square into del square u upon del y square, this is equals to n into n minus 1 u. This is the second important point. So Euler's theorem states that if u is a function of x and y and it is a homogeneous function of degree n, then these 2 points do follow. Please remember these 2 conditions for a function to satisfy the Euler's theorem. And for example, if we have been given the function if u is equals to x to the power 4 dot y to the power 4 upon x plus y. So this is a homogeneous function of degree 7 because 4 plus 4 8 and minus 1 7. So according to the Euler's theorem, x into del u upon del x plus y into del u upon del y, this is equals to 7u because here the degree is 7, and x square into del square u upon del x square plus y square into del square u upon del y square, this is equals to n into n minus 1 into u. So n into n minus 1 into u. So this would be 42u. So this is actually the interpretation of this Euler's theorem in this question. So let us do a question which is based upon the Euler's theorem. And the question that has been given us, let u is equals to tan inverse x cube plus y cube upon x minus y. And it has been given this is not homogeneous. This is not a homogeneous function, but tan u is equals to x cube minus y cube upon x minus y is actually a homogeneous function of degree equals to 2. So the first thing, that is x into del u upon del x plus y into del u upon del y, this is equals to n times f of u upon f dash u. Now we are going to use this funda because we have been given tan u. We have not been given simply u. So this would be 2 times tan u upon sec square u. So this would be 2 sin u upon cos u. Tan u can be written as sin u upon cos u into cos square u. So cos u ye cut gaya, so this becomes 2 sin u cos u or simply sin 2u. So this is coming out to be sin 2u. And secondly, x square del square u upon del x square plus y square into del square u upon del y square, this is equals to what? This is simply equals to let this is equals to g of u. So here we will obtain g of u into g dash u minus 1. So g of u is sin 2u multiplied by 2 cos 2u minus 1, because the differential or the derivative of sin 2u is 2 cos 2u. So this would be the answer. Okay, so that was all about the Euler's theorem. Now we shall be starting with the important topic of maxima and minima. Okay, so in maxima and minima, when please remember when we were differentiating the function with first, or we were obtaining the first derivative of the function, then first derivative was giving us the slope, that is dy by dx is actually giving us the slope, and the second derivative is actually giving us the nature of the curve, that is whether it will be a concavity case or whether it will be a convexity case. So a curve can be a concave or it can be a convex also. So if dy upon dx this is equals to 0 and d square y upon dx square is greater than 0, then this is corresponding to the point of minima. Okay, greater than 0 आ रहा है तो हो जाएगा minima, और less than 0 आता तो हो जाता हमारा point of maxima. So in case of minima, the slope is changing from negative to positive. For example, we have a curve like this. So at this point dy by dx is equals to 0. Here we have dy by dx is negative because if we take the slope at this point, so this is actually the slope that is anti-clockwise from the x-axis, and this is obtuse angle and hence the slope is negative, whereas here the slope is theta and it is acute and hence dy by dx is positive. The slope is changing from negative to the positive, that means we are having the case or the point of minima, and this is the concave nature. And say if the first derivative is 0, then second derivative is also coming out to be 0, and third derivative is non-zero, then this is corresponding to the point of inflection. And I already told you that the critical point in thermodynamics was also corresponding to the point of inflection. And if the dy upon dx is equals to 0 and d square y upon dx square is less than 0, then this condition is corresponding to maxima, and it simply means that the slope is changing from positive to negative. So if we see, the graph is somehow going to be like this. So at this point dy by dx is equals to 0. In this region the dy by dx is actually positive, and here dy by dx is actually less than 0, because if we draw a line, then the slope here it would be positive and here the slope is negative. Okay, so this was about the point of maxima. So this is corresponding to the point of maxima, and this is the convex shape. As we are looking it from the upward. So how will we represent the point of inflection? For example, if we draw the graph of y is equals to x cube. Now the graph of y is equals to x cube. This is actually the point of inflection. Because dy by dx is equals to 3x square, and at x is equals to 0 this is equals to 0. Then d square y by dx square is equals to 6x, and at x is equals to 0 this is also equals to 0. But if we take d cube y by dx cube, this is coming out to be 6, which is not equals to 0, and hence this point is the point of inflection. Okay, this is the point of inflection because this is non-zero value. So if the third derivative is coming out to be non-zero, then the point is corresponding to the point of inflection. Now there are some important note points, and the first important note point is the absolute minima of f of x, we're talking about the absolute minima, the absolute minima of f of x in the interval of a comma b, that is the closed interval of a comma b, is defined as the minimum of f of a, f of b and all its relative minimas in the interval of closed a to b. Okay, so this was the first important point, note point, and the second note point is the absolute maxima of f of x, absolute maxima of f of x is defined as the maximum of f of a, f of b and all its relative maximas in the closed interval of a to b. मतलब हम a पर फंक्शन की वैल्यू निकालेंगे, b पर फंक्शन की वैल्यू निकालेंगे और सारे रिलेटिव पॉइंट्स पर भी देखेंगे विद इन a एंड b, तो हमें मिल जाएगा मैक्सिमा. और हमें कौन सी वैल्यू निकालनी पड़ेगी? मैक्सिमम वैल्यू. और यहां पर मिनिमा के केस में हमें मिनिमम वैल्यू निकालनी पड़ेगी. And we must note one more important point, that if interval is given, then we go for the absolute value, and if interval is not given, then we go for the relative maxima or relative minima. For example, what is the maximum value of a cos x plus b sin x? Please remember, these are the standard cases, and the maximum value of a cos x and b sin x is actually given by under root of a square plus b square, the maximum value. So since interval is not given, then we are actually referring to the relative maxima. And what is the minimum value of a cos x plus b sin x? This is simply minus of under root a square plus b square. Okay. So what we are going to do is, we are now going to discuss a question. Say x square plus 250 upon x. This has been given as f of x. And it has been asked that this function f of x at x is equals to 5 attains. It attains what? Okay. So f of x has been given as x square plus 250 upon x. So f dash x is given as 2x minus 250 upon x square. So f dash 5 क्या हो जाएगा? F dash 5 would be 0. Okay, f dash 5 would be 0. क्योंकि जब हम x को 5 रखेंगे तो ये हो जाएगा 10 और ये भी हो जाएगा 10, तो 10 minus 10 0 हो जाएगा. Now f double dash x, this is 2 minus 250 into 2x upon x to the power 4, and this is coming out to be positive. Okay, this is coming out to be positive. So, or after simplification we will obtain 2 plus 500 upon x cube. So this will be positive. So function is actually attaining a relative minima. It is attaining a relative minima. Why? Because it is moving from 0, then it is becoming positive. So definitely it is moving towards the relative minima. Why we are giving the name relative? Because we have not defined any interval. Okay. So now let us do one more question, and the question has been asked: the maximum value of f of x such that this has been given as x cube minus 9x square plus 24x plus 5 will be in the interval of 1, 6. So this has been given as a, this has been given as b. So let us first find out what is f dash x. So f dash x would be 3x square minus 18x plus 24, and this is going to be 0. Okay, so since this is 0, let us simplify. That is, after taking 3 as common, we get 3 x square minus 6x plus 8 is equals to 0. And from here the two values of x would be 2, 4. So what we will do is, we will find out the value of f of x at 2, 4, 1 and 6. So f of 2 would be, if you calculate, it is coming out to be 25. F of 1, if you calculate, it is coming out to be 21. F of 6, if you find out, it is equal to 41. And f of 4 is coming out to be about 21. Now corresponding to 6, we are getting the highest value. This is 21, 41, 25 and 21. So this is the highest value. So the maximum value is 41 and hence this is the answer. Now let us solve a word problem, and we have been given that find out the height of the right circular cone of largest volume. Right circular cone of largest volume that can be inscribed in a sphere of 1 meter radius has a height of. Now what would be the height of that right circular cone which can be inscribed in a sphere of radius 1 meter? Now we will draw the diagram. This is the sphere, and let us say that this is the right circular cone. Okay, this is the height of the cone. Okay, this is the radius of the cone, and let us join with the center, and this center is radius, that is equals to 1, and this is nothing but under root of h minus, sorry, if this is complete h, this part would be h minus 1. Of course it would be h minus 1 because this is also 1 and this is complete h, so this becomes h minus 1. So h minus 1 whole square plus r square is equals to 1, and volume is equals to 1 by 3 pi r square h. This is for the right circular cone. So now we will use this relation, that is h minus 1 whole square plus r square is equals to 1. So r square is equals to 2h minus h square. Okay, and since volume is equals to 1 by 3 pi r square h, so 1 by 3 pi, instead of r square we will write 2h minus h square into h. So this would be pi by 3 2h square minus h cube. So v dash, that is differential of volume, would be equals to pi by 3 into 4h minus 3h square, that is dv upon dh. We are obtaining dv upon dh. So after this, v dash 0 would be equals to 4h minus 3h square is equals to 0. So h 4 minus 3h is equals to 0. So from here two values of h can be obtained. First h is equals to 0, then h is equals to 4 by 3. So v double dash would be pi by 3 4 minus 6h, and if h is equals to 0, v double dash is going to be greater than 0, and at h is equals to 4 by 3, v double dash is less than 0. So greater than 0 corresponds to the condition of minima, and less than 0 corresponds to the condition of maxima. And since the volume has to be maximized, so h should be equals to 4 by 3. So the maximum height that we have asked is h is equals to 4 by 3. So this becomes the answer to this question. So I'm just solving one question of a type, and rest can be solved in the similar fashion. Now we will start with the maxima and minima for a function of two variables. Okay, now we will have maxima and minima for a function of two variables. Okay, so we have been given u is actually a function of x, y. So what we will do is, first is we will find out del u upon del x and del u upon del y. And second is we will solve the equations and equate them to 0 and get the stationary points. We will obtain the stationary points. Third is we will find out r is equals to del square u upon del x square, s is equals to del square u upon del x del y, and t is equals to del square u upon del y square. We will find out r, s, t at each of the stationary points. At each stationary point. Now first condition, if rt minus s square is greater than 0 and r is also greater than 0 at the stationary point, then the point is said to be the point of relative minima. Okay. Second is, if rt minus s square is greater than 0 and r is less than 0, then the stationary point is said to be the point of relative maxima. Third point, if rt minus s square is less than 0 at the stationary point, then the point is called as the point of inflection. Then it is called as the point of inflection, or it is also called as the saddle point. It is also called as the saddle point. And fourth is, if rt minus s square is 0 at a stationary point, then there is no conclusion can be drawn. And here, if rt is equals to s square, then this is a doubtful case. Then this becomes the doubtful case, and investigation is needed to determine whether f of xy is actually going to be a maximum or minimum. Okay, so for gate we are only going to consider these top two cases, and this case may or may not come, but this is not considered for gate. This is a probable case that it may come, but definitely these 2 points are very important. So let us do a question based upon this. We have been given f of xy is equals to 2x to the power of 4 plus y square minus x square minus 2y, and this function is having a relative maxima or minima at. We have to find out those points at which this function is having a relative maxima or minima. Okay, then we will first find out del f upon del x. This is equals to 8x cube minus 2x. Okay, and if del f upon del x is equals to 0, then we have 8x cube minus 2x is equals to 0, that is 2x, 4x square minus 1, this is equals to 0. So we have the points as x is equals to 1 by 2 or minus 1 by 2, and x is equals to 0. So we have got 3 points, and that is, if we keep del f upon del y, that would be equal to 2y minus 2, and del f upon del y, if equated to 0, we can find out that y is equals to 1. Okay, y is equals to 1. So the possible points would be 0, 1, then 1 by 2, 1, and minus 1 by 2, 1. So we have obtained the 3 sets of points. Now we will find out r, s, and t. Now r is simply del square f upon del x square. This is 24x square minus 2, and s would be del square f upon del x del y. This is coming out to be 0, and t is equals to del square f upon del y square. This is coming out to be 2. So the value of r at 0, 1, this is coming out to be minus 2. Okay, and t will be 2 only, because r ही vary कर सकता है, t 2 रहेगा और s तो हमेशा 0 ही है. So if we calculate rt minus s square, this would be minus 2 into 2 minus 0 square, this is coming out to be minus 4. Okay, so rt minus s square is less than 0, therefore 0 comma 1. Now we will find out what is 0 comma 1. Now since we know that rt minus s square is less than 0, this is actually a point of inflection. This is a point of inflection. But if we check at the point 1 by 2 comma 1, then r is coming out to be 4, s is 0, t is 2, so rt minus s square is coming out to be 8, which is greater than 0. So this is the point of relative minima. So point of relative minima would be 1 by 2 comma 1. This is corresponding to the point of relative minima. Okay, so with this we come to the end of this particular lecture. In the next lecture we shall be studying about the gamma functions, the beta functions, and the area bounded by the curves and vector algebra. So I hope that you people are liking our lectures. Do give us your positive and valuable feedbacks on our YouTube channel or on our Facebook page. You can also rate our Facebook page, and you can also download the entire study material absolutely for free from our channel. So I would start with my gamma function, beta function, then area under the curves and vector algebra in the next lecture, and that would be the final lecture of mathematics. We are not going to discuss about Laplace transformations, because I request you to kindly do it from some standard book, because that is not very important in mechanical gate. You can simply note down the formulas and simply learn the formulas of cos, sine and tan, and that is it. So in the next lecture we shall be covering the remaining portions. So thank you so much.